Hello, thank you for joining us for today's webinar, PVC Pipe Safety and Sustainability, presented by Westlake Pipe and Fittings. I'm Emily Burdett-Kawak, and I will be your moderator today. Before we get started, here are some tips to enhance your webinar experience. We recommend you close email, messaging apps, and any other programs not currently in use, as they may interfere with the smooth reception of the webinar, causing buffering and poor sound quality. Technical assistance can be found at the GoToWebinar technical support page at the list linked in your handouts and on the slide shown. I also need to inform you that the mention of specific products or services in this webinar does not represent AWWA endorsement. AWWA does not endorse or approve products or services. We'll save time for some Q&A at the end, but you can submit questions anytime to our presenters during the webinar by using the question pane in your browser. All right, finally, I'll hand things over to Angie Bidlack of Westlake, who's going to introduce today's panelists.
Thanks, Emily, and thanks everybody for joining us today. Regardless of where we're located geographically, topics of sustainability and safety, especially pertaining to health and environmental effects, really seem to be top of mind with designers and owners, and rightfully so. So Westlake's very excited to have this opportunity to partner with AWWA and independent subject matter experts in these fields to share their knowledge and experience so that all stakeholders can make fully informed material decisions. As Emily mentioned, my name's Angie Bidlack. I'll be kind of a co-moderator today. Personally, I am a specification engineer with Westlake Pipe and Fittings. My job and that of my counterparts is to act as a technical expert resource within the water and sewer industry on all things pipe and fittings from design to construction. So for those of you who may not be familiar with Westlake, we're a manufacturer of PVC pipe and fittings. We have locations throughout the US and Canada, as you can see here. And a lot of you probably know us under our former brand names of North American Pipe, or NAPCO for short, Certainty, or even Royal Pipe. We believe that providing the best solution isn't simply linked to what traditionally has been used in the past, or even just a pipe's ability to efficiently convey drinking water consistently through a century of design life, although PVC most definitely does that. But we also, as a company, have sustainability, safety, and innovation as part of our culture, and that makes today's subjects as important to us as it does to designers and end users. So next slide, please. We're joined today by two experts. They're fully independent from Westlake and fully independent from the PVC pipe industry as a whole. And more importantly, their breadth and depth of knowledge is well beyond what I can ever hope to achieve. And they're going to be able to provide you a really deep outsider perspective. So today's session will be in two parts. And our first presenter is Mr. Tad Rudzinski. Mr. Rudzinski was formerly the EPA's Waste Minimalization National Expert. He is currently the co-founder and president of Sustainable Solutions Corporation, where he provides consulting and training for decarbonization strategies across companies in a wide range of industries, and he's acted as a trusted advisor in that capacity for over 30 years. Tad has also done work in academia. He was instrumental in the development of Villanova University's Master of Science in Sustainable Engineering program, and also taught as an adjunct at Villanova for 18 years. And those classes included Advanced Life Cycle Assessment and Introduction to Sustainable Product Innovation. So Emily mentioned we'll be keeping an eye on questions throughout the presentation. Please type them in at any time, but we will be holding those questions until after our second presenter, which is Dr. Ron Breacher. Dr. Breacher holds a PhD in medicinal biochemistry from the University of Sussex and is a chartered chemist and a diplomate of the American Board of Toxicology. He's practiced toxicology for more than 35 years, focusing on risk assessment and risk communication related to human exposure to chemicals in the environment, food, and products. Dr. Breacher has established an excellent reputation for communicating complex scientific concepts in plain language and has served as an expert witness in environmental hearings and in criminal and civil legal proceedings. His work includes undertaking exposure and risk assessments, as well as developing, revising, or contributing to regulatory exposure limits. So again, After Dr. Breacher's presentation, I'll then post questions that have come in to both of the presenters. And if there are questions that we haven't got to due to time constraints, we'll follow up via email post-presentation. So again, please don't hesitate to submit. We want this to be as informative as possible, but we will get you out of here on time. And with that, I will turn it over to Mr. Tad Wazinski.
Thank you, Andy. Excited to be here today, and I want to welcome everybody to this webinar series. And we're going to start this out with a poll. So I want to ask you all, we have a very nice turnout on this. So is your organization requiring life cycle data or environmental product declarations when selecting pipe materials? It's very simple, just answer in the poll yes or no, and we'll see how the poll is going here and get some data. And the reason I'm doing this is I want to understand what's driving the market for all of you in terms of how you're thinking about the piping materials that you're using. So trying to see how the poll is going here. All right, so we have about 70% of you that have said no, you're not requiring life cycle data or EPDs, and about 30% of you have, so that's great. So we have a mixed audience here of people that are trying to understand, you know, what is the life cycle of pipe and what are the environmental impacts of pipe. So that's really excellent, so thank you. All right, so now I'm going to take control here. Okay, I don't know why. Can you all see my screen?
Yes.
Okay, great. All right, so what we're going to talk about today is, okay, I'm not seeing my screen on here. I don't know what's going on here. Very sorry here. All right, great. So let's, if we can advance the slide, that'd be great. So before I get into this, I want to talk about what is a sustainable piping product. And one thing to think about here is when we think about pipe, you know, there's going to be certain specifications or requirements that you're all going to follow as you drive forward in designing the next water system or sewer system or stormwater system. And, you know, most of you are going to be thinking about, all right, what are the requirements in the particular municipality or within our own systems that we have to follow? What type of soils are we dealing with? What is the flow rates? All these different things. But when we're thinking about holistically about pipe and we think about what is a sustainable product or what is a sustainable piping product, we really have to take a long view and think about a multi-attribute approach. And it's really important to be thinking about the lifetime is a big one. And we are definitely looking for products that can last at least 100 years. We're also thinking about the fact that, and I'm going to show you this in a few minutes here as we go through some of the life cycle data that we've done, that pumping energy has a big impact of actually the piping system. We're going to see that the actual manufacturing of the pipe, the installation, et cetera, are not that significant when you think about running water and pumping water through a pipe for 100 years. We also have to think about things like corrosion resistance, maintenance, lower embodied energy and lower embodied carbon. I'm going to talk about what that means. And then another big thing when I asked the question about looking for EPDs or looking for LCAs, I was basically trying to understand if you were looking for transparent disclosure of environmental impacts of the piping systems. And then we'll also be thinking about, you know, break rates and is it recyclable at the end of life? And Dr. Ron is going to talk a lot about no lead or leaching or other chemicals. That's another thing that we have to consider. So definitely want to tee that up here for him. And again, taking a long view, taking a life cycle lens on what products you're selecting, and the multi-attribute approach is really important. So if we go to the next slide, I'm going to now talk about basically life cycle thinking. And when we're thinking about life cycle of a pipe, and just to give a little background, I am actually a mechanical engineer, and I started my career when I was 19 years old as a piping designer, and got to really get to understand piping systems and all types of things. And then I eventually got my bachelor's degree, and I continued on as a piping engineer and a mechanical engineer, and then moved on to different things. And now our company does a lot of life cycle assessment. And when we're looking at various products, we're trying to understand the impacts of a product from the raw materials, starting all the way at the very beginning of, out at the natural gas well or the salt mine or, petroleum extraction point or whatever, and then basically getting those raw materials, making it into the various materials, and then manufacturing that particular product. From there, the pipe is made, it gets transported out to the marketplace. It then gets installed, and you're going to see that installation definitely has an impact when it comes to putting the pipe in the ground. So that's really important when we think about what we put in the ground, that we want to make sure we don't have to dig it up and replace it in a short duration of time if it fails prematurely. And then we think about what happens at the end of life. Majority of you are probably just going to leave the pipe in the ground. You're not going to, take it out unless you have a major break or something. But we have to think about it. If we do need to remove pipe, can we actually recycle it at the end of life, and what can we do with it? So if we go on to the next slide, I'm going to show you a visual of what a life cycle of a pipe actually looks like. And you can see here we have multiple ingredients, like I said, that come into making a pipe. In the case of PVC pipe, it's going to start out with PVC resin, impact modifiers, a lot of other additives that will be basically sent to a manufacturing company like Westlake. They'll then actually extrude that pipe into the various shapes, sizes, thicknesses, etc., and then send it out into the marketplace, where it then gets installed and used. And again, ideally, we want the pipe to be used for over 100 years or more. And then at the end, what happens at the end? Again, it either stays in the ground or gets removed. So if we go on to the next slide, we're going to be able to see here that this is actual data from a life cycle assessment we did. And I'm going to be talking a lot about this information today, because we did a study of not only PVC pipe, but we looked at a lot of other piping materials. We did the first study in around 2013, 2014 timeframe, and we analyzed various pipe systems. And our company came into it completely unbiased. We just wanted to see what were the environmental impacts of these various pipes, and what ones made the most sense in terms of taking that multi-attribute lens like I talked about. So you can see here, this is actually data that comes out of a life cycle analysis. And the thing that you see there, you see GHG emissions. That's actually measuring the greenhouse gas emissions of the overall life cycle of a pipe. In this case, the blue represents basically the manufacturing of the pipe, the raw materials, and then the installation. And then the orange actually represents the energy that goes into moving water through that pipe for 100 years. Because think about it, if you're under a pressurized system, there's going to be pumping energy. There's also friction in the pipe. So we want to select pipe that's going to be smooth and have very little corrosion over time, and allow that pumping energy to stay consistent for the long term. And there's a lot of studies that have been done on different friction factors and the roughness of the pipe and all that kind of thing. So being able to really understand that is a big deal. And what we're looking at here is basically a functional unit of 100 feet of piping over a lifetime of 100 years. So as you can see here, based on the size of the graph, the greenhouse gas emissions of actually making the pipe is maybe about 18% of the total impact of the product, compared to the 100-year lifetime of pumping energy through that pipe. So really important to note here. And then there's other impact categories that you can see here. Not only do we look at the global warming potential or greenhouse gas emissions that are associated with all the steps in the life cycle, we're also looking at the total energy that went into it. That's cumulative energy demand at the end. And then there's other impacts that, like smog, acidification, eutrophication, things like that. So again, we're going to zoom in mainly on the embodied carbon or the greenhouse gases that are associated with the pipe as we go through the presentation. Next slide, please. So if we think about use phase, we do know that from studies that about 4% of all electricity in the US is consumed for pumping water. And that's a big amount of electricity, actually. It represents about 56 billion kilowatt hours of electricity per year. I worked in electric utility for 12 years of my career. And that's equivalent to about 45 million tons of greenhouse gases to the atmosphere. So this is why we need to be thinking about the pipes we put in the ground. Not only do we want to select the most sustainable material, but what is the material that's going to provide the lowest impacts when you're pumping that water for the next 100 years. And in a few minutes, we're going to be talking about why this is important to many cities and provinces and states and all types of different government agencies as they're looking at this. So if we go on to the next slide, we're going to talk about transparency now. If we click one more, we're going to be able to talk about EPDs. So I mentioned in the poll question, what is it, LCA? Are you looking at that data? Are you also looking at environmental product declarations? When we conduct a life cycle assessment, it's a very detailed, intense study, lots of data, lots of science. We collect a lot of what we call primary data from manufacturers. So in this particular case, when we worked with the Unibel PVC Pipe Association to create this environmental product declaration you see right here, we basically had to work with the association, and then we worked with many of their members, including companies like Westlake, to collect actual data on what were the raw materials they were using for various pipe profiles, what was the energy, water, waste, emissions, everything that went into their manufacturing stage, what was their typical transportation distances, a huge ton of data that we had to collect. And then we ran that information through our life cycle assessment software to understand the environmental impacts like I showed you in the previous slide. Now that study was a gigantic report, probably like 120 pages long, lots of data, lots of tables, lots of complicated information that typically the public doesn't want to consume. So what has been designed is a thing called environmental product declarations that condenses all that information down into a format that allows you, the designers and the engineers and the municipal officials, the sustainability experts, to look at this information and to see what were the various impacts of the pipe products. In this particular case, our focus in this environmental product declaration was PVC pipe, and we looked at PVC and PVCO, and as well as pressurized and non-pressurized pipes. So this information basically was done. It was a critically reviewed document through NSF. They were the program operator. We follow international standards to make sure that we are completing this document in a very fair and consistent manner, following the standards. We then did the LCA, and then we pulled in a three-party critical review panel because we were, basically making assertions about comparing this to other piping materials and everything else. And that three-party critical review panel was made up of an expert on LCA, an expert on engineering design and water systems, an expert on energy and piping system energy that's required for pumping. And they did a very detailed review of the study that we completed. So this document is out for public consumption. Anybody can utilize this. For those of you that are designers and engineers, I would highly recommend that you grab this document and start to look at it and understand it and use this information when you're making selections on pipe. And we're going to talk about some standards in a few minutes that are driving changes and ways you can look at sustainable infrastructure and sustainable piping systems. So this is fully available out in the marketplace. If you want to go to the Unibel website, you can download this. Like I said, third-party critically reviewed by NSF International, as well as a three-party critical review panel to evaluate this document. Okay, if we go on to the next slide. So when we looked at this, like I said, that's a second version of an EPD. We did the first version around 2013, 2014 timeframe. And basically what we did is we understood what were the impacts across the vinyl value chain. And we could see that a typical pipe, the global warming potential or the carbon footprint of making that pipe was what you see here in the blue line, the 100% line. So we did that by looking at all the energy and everything, raw materials that went into the pipes. And then there's an organization through the Vinyl Institute called the Vinyl Sustainability Council that has pulled together a whole initiative that includes guiding principles, educating and working with all the different folks and manufacturing companies across the vinyl value chain. That includes the resin producers, the people making the additives, you name it, anything to do with pipe. Are members of this organization, and they all have been really focused on reducing their impacts in the manufacturing process. So reducing their energy consumption in manufacturing, looking at better ways to save water, looking at all kinds of things they can do from a sustainability perspective to drive down those impacts. And what that means is when we run the second LCA and the updated data in that EPD that I just showed you in 2021, we see across the board an impact reduction for vinyl pipe. So what this demonstrates is that the value chain, the resin producers, all the raw materials manufacturers and ingredient manufacturers, as well as the pipe manufacturers, have done a really good job of trying to drive down their energy consumption and reduce their own carbon footprints and make a more sustainable product. So across the board, we saw about a 6% reduction in impact. We've also seen that this is associated with manufacturing impacts across the value chain. We've also seen that the raw materials did remain similar, so there was no changes in recipes or anything that would have skewed this data. And we did see that the PVC resin manufacturers, which makes up a huge amount of the ingredients in this pipe, did a really good job also of reducing their impacts in their operations across the board. So again, this shows continuous improvement. This shows that the vinyl industry across the value chain, including Westlake and all the pipe manufacturers, are fully committed to meeting guiding principles around holistic sustainability of piping systems and products, and they're working to really continuously improve and reduce their impact over time. We go to the next slide, please. So let's talk about, PVC pipe as a sustainable material. If we click one more, we're going to see here, this is some of the data that's in the LCA report from our analysis. And one thing I want to point out here is if we look at other piping materials, and like I said, I went into this completely unbiased. I didn't know what we were going to see. We didn't know if PVC pipe would come out with higher impacts of other materials. We didn't know what to expect. But if we look here at this PVC DR18 pipe, we're looking at embodied energy here, which is very similar to embodied carbon, very similar impact. And you can see here that the use phase in this particular case is the green bars on all these pipes. We have PVC, we also have high density polyethylene, and then we have ductile iron as a comparison here. We have final transportation installation, then we have cradle to gate, basically means the raw materials in the manufacturing stage. And we can see here the 100-year embodied energy for 8-inch PVC pipe is for the PVC is significantly lower than the HDP and the ductile iron. So the lower the graph, the lower the embodied energy, means that you've got reduced in carbon emissions as well. As you can see here, the use phase energy is significantly higher on the HDPE because we tend to find that has a smaller diameter because you have to go with a thicker wall on that material, which means more pumping energy. On the ductile iron, you can see there's an assumption there that over time there's going to be some internal corrosion on the pipe as the pipe corrodes. So that's why we can see this data. But bottom line is, if I'm looking at science and I'm looking at good data, this hands down shows that the PVC pipe over its 100-year lifetime should have lower environmental impacts. We go to the next slide. Now, what I'm looking at here is same thing, but I'm thinking about looking at the PVC pipe, and you notice the little dashed bars ahead, like above each pipe material there. That assumes that the pipe might fail in less than 100 years. And we looked at a lot of data on that to determine what is typical break rates, typical failure rates of various piping materials. So that gray bar or that dashed line basically represents what would happen if the pipe failed in 30 years or 50 years or even 60 years, didn't last 100 years, with the assumption that the PVC pipe will, what would be the impact if I had to basically dig that pipe up and replace it if it failed? And you can see here, it basically doubles the overall impact of the piping material. So if we look at this, the HDPE, the ductile iron, and then we basically looked also at concrete pipe. You can see there, we've got the hydraulic energy from pumping. We've got, different things like for ductile iron, you also have to include that there's corrosion protection added to the pipe, as well as cathodic protection put in the ground to help minimize failure of the pipe. So we added that in. So again, hands down, you can see that the PVC pipe over the other pipe materials is definitely lower. And this is a 24-inch size pipe here. So giving you a broad range of different pipe sizes for you to consider as you're looking at this. So let's go to the next slide. And some things I want to really point out here, knowing that we have a lot of people on here that are doing design work. Like I said, I'm a piping designer from my early days, an engineer. We want to definitely be recommending that you utilize life cycle thinking when you're designing your piping systems, thinking about the entire life cycle and the pumping energy, what's going to happen. Definitely using like life cycle data from an EPD or a life cycle study, and basically deciding what pipe material, using that multi-attribute approach, is the best material that I should put in the ground for the long-term benefit of the municipality, the city, whoever you're doing the design for. And then it's really important to think about too that installation, we have found, does have a significant impact. So you want to put a pipe in the ground that's not going to fail. You want to put a pipe in the ground that's going to last really long, because every time you have to dig it up, you have to basically, dig up the earth. You're putting in fuel into the track hose that have to dig it up. You're refilling. You're having to pave. You're blocking traffic. There's impacts from that. So a lot of things to think about when you're doing this design. So if we go to the next slide. This is our second poll that I want to ask you all. So I'm going to ask you, is your organization following any sustainability standards to help guide the design of water systems or infrastructure projects? So this is a yes or a no. So if it's yes, you can select, are you using Envision, which I'm going to talk about. Maybe some of you know about it, some of you don't, but I'm trying to test to see if any of you use any of these or have heard of any of these standards. Envision is a standard for sustainable infrastructure. Then there's LEED Cities and Communities that has a whole infrastructure component built into it. LEED Neighborhood Design has an infrastructure component built in. If there's an other standard you're doing, you can click that box. Or if you don't use any of these standards, just click no. So in a second here, we'll be able to see the results of the poll. And this is, again, just to get a feeling for, are any of you using this? I'm assuming that some of you that clicked yes on using LCA or EPD data might be using some of these standards, so it'll be an interesting poll to see. So maybe we could see the results coming up here shortly. All right, so we have about 69% that said no, then that's expected. We have about 7% of you that say you use Envision, 8% are using LEED Cities and Communities, 1% saying LEED Neighborhood Design, and about 15% said other. So it'd be interesting to know what the other is. If some of you want to put that into like the question pane, what the others are, that'd be interesting for us to understand and learn. But this is great data, so thank you for putting this in here, and thank you for participating in the poll. Next slide here, if we can advance. So I'm going to tell you a little bit about Envision. I'm going to go into a little more detail. We saw about 8% of you are using that. So Envision is a guide to designing sustainable infrastructure. It's put together by the Institute for Sustainable Infrastructure, and it looks at multiple things here, like reducing net embodied energy, supporting sustainable procurement practices, reducing energy consumption, and reducing greenhouse gas emissions. So if you see these bullet boxes popping up, conserving energy by reducing the net embodied energy carbon of the project materials over the project life, that's using that EPD information to say what pipe material is going to have a lower embodied energy and then a lower embodied carbon that I should be using to make this system more sustainable. The conserving energy piece means what's that energy going to be over the 100-year lifetime? Again, that data can be found in the LCA data and EPDs that have been done by the Unibel Pipe Association. And then conducting a comprehensive life cycle carbon analysis to reduce the anticipated amount of net greenhouse gas emissions. That's exactly what I just showed you, that the entire vinyl value chain just did. They looked at what was our baseline in year 2013, 2014, and then the industry basically learned from that, tried to reduce impacts in their manufacturing. The raw material producers try to reduce impacts in their manufacturing. And we got a net effect of about 6% reduction in embodied energy and embodied carbon in those products, which is amazing. So just imagine if they keep doing that continuous improvement, the next iteration of updating that LCA and EPD, we're going to see even more improvement. And then reducing the overall greenhouse gas emissions in the project is, really thinking about that over the lifetime. Next slide, please. So I just wanted to point out, this is important because this is a map that shows all the US cities that are supporting carbon emission reductions. And you can see there's a lot of them. Right now in this particular snapshot that we did, there was about 455. So think about it, if a city or a municipality is pumping water, and we know that 4% of that energy of pumping the water is a big deal to them, they're going to want to reduce their carbon impact of pumping that water over time. If we click again, we're going to see that there's Canadian provinces that are doing this as well. So anything with color on this map is showing where the commitments are for reducing carbon emissions in their operations. So if we go to the next slide, I think that's it for me. So I'm going to turn it over, and I'll be happy to answer any questions that you have. I'll turn it over now and to Ron to talk about all the interesting information about the health and safety of the pipe. Thank you.
Hello, everybody. I'm just going to get my slideshow up. And can somebody just confirm that you can see my screen okay, please?
Yes, we can see it.
Great, thank you. So thanks very much for having me today to talk about the safety characteristics of vinyl pipe. It was mentioned in the introduction that Tad and I are both independent consultants, and that is true. I've worked for industry, government, non-government organizations, all types of special interest groups. As a subject matter expert, it's very important to me to give the same answer no matter who's asking the questions. And like Tad mentioned several times, I go into this kind of work with a very open mind. I'm not sure what I'm going to find, but I've been working on vinyl information for a long time, very long time. And I have started to see a pattern, not just in the information, but in misinformation. And I'm going to try and correct some of that today. So I want to talk, before I get into some of the data, I want to talk about what safety actually means in this context, and then the relationship between sustainability and safety. I want to look at some of the types of misinformation that really seem to dominate discussion around vinyl safety, and then provide you with some credible safety information about vinyl pipe. We'll look at a couple of other aspects of safety, and then I will wrap it up. Now, I said I've been working on vinyl for a long time. The first time I ever did any work on vinyl was in the late 1990s, when I was asked to speak to Toronto City Council about the safety of vinyl. There had been a proposal to deselect vinyl as a building material for the Olympic bid that Toronto was putting in. And some constituencies wanted vinyl to be banned from the list of ingredients. So I actually gave my deputation at 3 in the morning. There were 5-minute deputations. I gave it 3 in the morning, right after the Raging Grannies singing Silent Sperm. So you can imagine that type of event really stays with a young scientist. And I really tweaked on right away at that time to how much misinformation there was about vinyl and how fear can be used to drive decision making. So as a scientist, it's very important for me to provide information dispassionately so that people can make whatever decision they want to make. You can't tell people what to worry about, of course. They'll worry about what they want to, but as a subject matter expert here, when I'm asked, I want to tell you what I know about vinyl safety. So we've been using this word safety. I went online and I found a few definitions, and you'll notice I've highlighted a few words like unlikely, not likely, it depends. I didn't see anywhere where it said that for something to be safe, the risk has to be zero. And I think most of us can identify many areas of our lives where we accept certain risks and yet we still feel safe. And the reason why I have the graphic of the traffic lights at the bottom is that I suspect there are some people in the audience today who drove through a green light recently. And we do that assuming it's safe, but a lot of traffic accidents happen when people drive through green lights. So there's the concept of relative safety. Paracelsus said it 500 years ago, risk depends on exposure. One of the things that I find in the misinformation that I see about vinyl safety is that it's very hazard focused and avoids talking about exposure. A lot of times when you find the exposure is zero, that will mean the risk, of course, is zero. So with that little background, let's go back to a diagram that looks similar to some of the things that Tad was showing you. This comes from a different study from Purdue University in 2015. But again, it shows different types of life cycle impacts of different piping materials, including concrete, ductile iron, fiber reinforced polymer, and polyvinyl chloride. You can see that with the exception of the purple bar, which is fossil fuel consumption for concrete, every contribution in the PVC pipe life cycle is less than every other category. And the overall score in terms of life cycle, you would rate PVC as the most favorable here. But how do we connect some of this to health? Well, some of the health metrics are tied up in these things down at the bottom here. Now, arguably, I could argue that fossil fuel consumption, degradation of the natural environment, ecotoxicity, which could affect natural foods and other things, all of those things in theory could affect health as well. But I'm really going to focus in these four categories: respiratory, inorganics. Those would be things that don't contain carbon that you can breathe, carcinogens, chemicals that cause cancer, breathable organic chemicals, those would be chemicals that that contain carbon, and radiation. Now, if you look at all four of these alternatives, I think we can get rid of radiation right away. It's not significant in any of the alternatives. The same is true for the respiratory organics. They would have an orange bar down here near the bottom, and there isn't one. So there's really not much impact there. Where you see most of the differences are in the respiratory inorganics and the carcinogens. So let's have a look at some of those. So this is where the most common safety questions about vinyl pipe congregate. This is the kind of main list. People are concerned about vinyl chloride monomer, which is a carcinogen. They're concerned about dioxins. We all know about dioxins, particularly in the past from places like Love Canal. Phthalates have been an issue. Phthalates are plasticizers that are used to soften vinyl. And of course, metals like lead and tin stabilizers. So let's go through these kind of one at a time. So I've put these three together because they're all organic, but we'll talk about them one at a time. And vinyl chloride. So first of all, this is a brief that was prepared for the PVC Pipe Association. And it talks about vinyl chloride. Obviously, in a 20-minute presentation, I can't go into all of these details and cover all the important topics. But the bottom line is in the last heading, leaching of vinyl chloride monomer is not an issue for PVC water pipes. This is an issue that was dealt with in the 1980s, in the 1970s. It was an issue in the past, but it is not any longer. NSF Standard 61, which we'll be talking about a little bit more, is even more stringent than EPA requirements. So vinyl chloride, not an issue. So let's talk about dioxins for a little bit. Whenever we need infrastructure, we're going to need pipe in the ground. So it's not a matter of whether we're going to put pipe in the ground, but what pipe we're going to put in the ground. And so it's not a matter of whether there will or won't be life cycle impacts. It's a matter of which has more. And that's certainly true for dioxins. So if you look at this graph on the lower right, it comes from an April 2017 life cycle assessment that was prepared by Tad's company. This compared dioxin emissions from US pipe and foundry plant and from a vinyl PVC resin manufacturing plant. You can see that both of them have emissions of dioxin that are greater than 0. The emissions from the vinyl facility are about 5 or so times lower, so much lower. And what's really interesting about that is you can see that those emissions have stayed the same or maybe gone down a little bit, even though the amount of vinyl that's been manufactured and used has gone up dramatically in the time that's shown on this graph. So although there may be some minor contributions of dioxin from the manufacture of vinyl, it is very, very tiny compared to any of the alternatives. Phthalates. I don't have a graph to show you about phthalates because phthalates just are not used in rigid vinyl pipe. Phthalates, I was on an expert panel that looked at the safety of phthalates in medical devices and children's toys. So phthalates are used to make vinyl softer. Sometimes they can be present at 40 or 50% of the mass of the product. As I said, you find them in toys, soft vinyl materials, blood bags. In fact, phthalates help, let's say vinyl blood bags that contain phthalates have a much longer storage life for blood than other types of blood bags. But there are no phthalates in rigid PVC, so I can't, they don't make a difference to vinyl pipe safety. They're just not there. So now let's look at the respiratory inorganics. Now, this is kind of a limiting category. When I'm looking at inorganics like lead, I'm not just concerned about them as respiratory problems. If lead is present in the water, you can be exposed by ingestion. You could be exposed by inhalation of water vapor while you're showering. So there's other pathways of exposure. We don't want any lead in our water. So the question is really, what's the role of lead in vinyl pipe? And similarly, tin stabilizers. There are some tin stabilizers, not the ones that are used in vinyl pipe, that may cause developmental issues and other types of problems, but they're not present in vinyl pipe. So let's look a little bit more closely at what the NSF says about lead and tin specifically, and then I want to look at this more broadly. So if you just look over on the right-hand page here, I know the writing is small, but what it says, according to NSF, January 2019, PVC pipes and fittings certified by the NSF do not contain lead. And for organotin compounds, all NSF certified pipe products are tested for metals at least once a year. Levels of the type of inorganic tin stabilizer for the product must pass the toxicology evaluation. And that's a comparison against the human health-based drinking water standard. So let's look a little bit more carefully about NSF 61. So I like standards provided that they're comprehensive. And you know, a standard isn't always just a number. A standard, it can be a code of practice, or even something like a speed limit is a standard, something that describes what you need to do or the benchmarks you need to meet. And this standard has three important components. First of all, the analysis. So all of the substances I've talked about today, things that would be expected to be in the formulation, all of those are going to be analyzed. So volatile organic compounds, phenolics, vinyl chloride, regulated metals, so that would include tin and lead, and any other substances that were identified during the formulation review. The second part is a toxicology evaluation. So the results get compared to US and Canadian drinking water criteria. They're not always the same, by the way, in Canada and the US, but I could say that American and Canadian drinking water standards are among the strictest in the world, the health-based standards. And finally, there's a verification component here, which is really unannounced audits with laboratory testing of materials. So this is a pretty robust verification of some of the things that I'm talking about today. The environmental product declaration, Ted mentioned this idea before, but this comes right out of the environmental product declaration, some of the attributes of PVC that I would, in my opinion, contribute to it as a safe product. First of all, it's resistant to chemicals that are generally found in water and sewer systems, so it tends to be very inert. That prevents any leaching or releases to the ground, outside, and surface water during the use of the piping system inside. And by the way, there's been a suggestion that there could be a concern about permeability of vinyl pipe. This is an unfounded suggestion, by the way, permeability of vinyl pipe from substances entering from outside a drinking water. Drinking water pipes are under pressure, and the pressure is greater inside than outside the pipe. So I think that would be very unlikely. So we also have no known chemicals released internally into the water system and no known toxicity effects in the use of the product. Those are very strong safety statements. And again, the PVC Pipe Association put together a technical brief on this topic. And one of the things that I want to point out here is that there were 7 PVC pipe manufacturers that participated in the life cycle assessment that was originally commissioned back in 2013. And all of those pipe manufacturers are declared. It's clear who commissioned the study. And let's face it, somebody has to pay for everything. So you can always raise questions about the source of funding for a study. But the fact that it was done by an independent consultant, the funders are named, it was reviewed by the National Sanitation Foundation. All of these things, again, provide an independent eye to support these claims of safety. There's a couple of aspects of safety that I don't really have time to drill into today. The first one I just want to touch on is occupational health and safety. So vinyl pipe is lightweight compared to all of those alternatives. So perhaps there's a benefit in terms of occupational health and safety, workers carrying heavy loads and so on. There's no sparks that are produced when you cut vinyl. Again, it's an occupational health and safety issue. And the long life of vinyl pipe means that you're going to be in the ground working on them less frequently. There's also evidence that when you chlorinate drinking water, Certain metals, including iron, can cause a depletion of the free chlorine. That's shown in the red and green lines in this graph. It's from that same April 2017 Sustainable Solutions report. The vinyl pipe is the blue line, and you can see that the free chlorine was maintained over a period of 12 hours in the case. So just to wrap this up, I would say that vinyl pipe has an excellent safety profile compared to the alternatives. And remember, when we evaluate safety, it's always going to be compared to an alternative because we need infrastructure. So it's not about whether we're going to put something in the ground, it's what will we put in the ground. So what supports that excellent safety profile? Well, the life cycle assessment results, both at a high level and when you break them down further. The NSF certification, which is basically keeping the pipe manufacturers honest and making sure that things don't change over time. The in-use experience with this material for so long, and perhaps some of the occupation safety benefits that I mentioned, and the fact that it's really non-reactive and inert. So with that, I'm going to wrap up my presentation. So I'll stop sharing my screen and turn it back over to the presenters.
All right, so let's start taking some questions for Q&A. I'll have everyone come back on screen and we will go ahead and get started. A good reminder that if we don't get to your question, they are passed on to the panelists who will do their best to answer you by email. So Angie, how about you ask some questions?
I would love to. And just kind of full disclosure, I am going to concentrate on the questions that are best posed to Tad and Ron. There were a lot of really great questions. Some of them were just generally PVC related and pipe related. And I really want to make sure we use the best uses possible of Tad and Ron's time today. So the first question is for Tad. Is there any consideration of capital cost in the life cycle assessment?
Well, there in the LCA, we definitely look at the overall environmental impacts and whatnot. You can do life cycle costing, there's no doubt. And we actually did do a study of the cost of energy as part of that for the various studies that we did in terms of pumping energy and things like that. So yes, we did include some of that. And typically, life cycle assessment might only focus on the environmental impacts, but you can bring in the element of what we call life cycle costing as well. And we did a portion of that for the pumping energy aspect of this. And I do know that there's a lot of studies out there that if you wanted to compare, you know, how much is HDPE versus PVC and that kind of thing, those exist, but we did not pull that into our study. So.
Thank you. We'll then go over to Ron. Ron is PFAS. There's a lot of, I'm paraphrasing a number of questions here. So new regulations around PFAS and PFOA in the EPA right now, lots of conversations about that. Are there any considerations underway of chemical leaching with PVC safety? And are there any plans you're aware of for an NSF 61 update?
Okay, so I think there were three questions in that. The first one is about,
trying to paraphrase.
Okay, so the first one is about PFAS and whether there's any issues, you know, or connection between PFAS and vinyl pipe. So first of all, I'm not aware of any studies that have specifically looked at that question. Bear in mind, there's thousands of PFASs, so we would need to know which PFAS we need to look at. Maybe PFOA, perfluorooctanoic acid, and PFAS, perfluorooctane sulfonate. The second, just to finish that thought, one of the problems with the PFAS, they're called the forever chemicals because they're inert. They're very unreactive. PVC, I've just finished telling you, is very inert and very unreactive. So if you take two things that are very unreactive and you put them together, I would expect not much to happen. That said, I don't think that work has been done.
Thank you for that.
Was there, oh, the third part was, am I aware of any plans to update NSF 61? And I'm not aware of whether there is or isn't an update going on.
Thank you. Tad, which software is used for an LCA?
Our company typically uses two softwares. There's CimaPro and Gavi. And I believe for the LCA work that we did, we use CimaPro as the software. And you can imagine when you do life cycle assessment, there's a lot of data, a lot of information. It's really complex, and using a software really makes it much more streamlined. I actually looked at a study that someone had done that they did it all in spreadsheets, and it is a gigantic spreadsheet when you start going all the way down to where the raw materials actually started, when, you know, whether it's the natural gas well or whatever. So definitely the software is very important. And that is, both of those softwares are used globally, and they're also updated, maintained, they follow ISO standards as well. So.
All right, back to Ron, because there were a lot of great questions for both you guys, and I want to make sure that I use your time equally. Is there any data on the leaching of microplastics and nanoplastics from PVC pipe?
Not that I'm aware of, but there is data on the presence of microplastics in municipal drinking water, bottled tap water, and other types of water. So not specifically leaching of microplastics of PVC. I am aware from some work that I did on this topic a while ago that PVC was a relatively minor contributor to microplastics overall compared to some of the polyethylenes, for example. But
Okay.
I haven't seen anything specific about microplastics from PVC pipe.
Okay.
These are great. One of the reasons why these questions are great is they're going to go back to industry. If people are concerned about these questions, the work can be done in a controlled, objective way to answer them. And, you know, one of the other things I wanted to mention when I was talking about safety and context, might sound kind of corny, but all the people in the industry, just like the people on the panel, the people in the audience, we all have families, we all drink water, we all have houses. It's just not really enlightened self-interest for the PVC industry to poison its own house and poison its own water. I really, you know, I've worked in this area a long time. I would say a lot of the conversation around PVC gets dominated by misinformation.
So do you have any following on to that question, do you have any pointers that designers and owners can use to evaluate that whether or not something is misinformation?
Yeah, it's kind of a lot of it is what our parents taught us about when you listen to somebody telling you something. How do they know what they know? What's their motivation for telling me this? Is the source independent and credible? Does it pass the sniff test? For anybody, I hate swearing on these things, but I'm going to give you the name of a video. If you're interested in watching how you can spot bullshit, there is a video and a book by that name by two excellent university professors. It's called Spotting Bullshit, and well worth getting and watching.
I want to just add to that real quick. The one thing that I would suggest is don't look at 140 characters on this thing and make a decision about is it true or not. You need to really look at the science. I mean, everything that we've talked about today was very science-based, and it was critically reviewed, independently reviewed. That's what you have to trust. When you start just getting that 140 characters on your phone and you say, oh, I'm going to make a decision about that, you know, that is not the way to make determinations of what's real and what's not when it comes to disinformation.
One of the reasons why scientists and engineers talk so much is that usually these things aren't simple. And if you can summarize it in 140 characters, you probably don't understand the complexities.
And with that,